Welcome everybody. Webinar number 10 for Bauplan today. We're going to talk about like Git for data, how agents write to production without breaking it. Ciro is here to present, a bunch of slides at the very beginning, and then we're going to move to a demo. Folks, as usual, please use the chat, to drop your questions. Use the Q&A tool if you prefer. We are here to have a conversation. Let's keep it as casual as possible and as useful as possible. Please, Ciro, you can go ahead.
I'll try to keep the slides to a bare minimum so we can jump into more interesting stuff. But yeah, so thanks everybody for coming. What we're going to be talking about is mostly how Git for data works, what that means, and how it is implemented. But most importantly, how you use it for certain very practical use cases that have to do with agents. Git for data is basically just like a general concept that will allows like basically data engineers and data practitioners to have the same ergonomics that we do have when we write code and we write software, that allow different people to work on the same code base together in a principled way. So you have ways to create branches that are isolated, and you have ways then to publish the work of different developers from the branches into the main branch, resolve conflicts, and roll back if things go wrong. And this concept is very instrumental in code development, of course, and in data is a concept that you can sort of grok together with abstractions like data versioning or like zero copy clone, but there's not really kind of like a Git for data model out of the box. And we think this is very useful, particularly for agents. In practice, what people, like our customers and practitioners do with the Git for data today is they address in the agentic era a problem that has been around in data since I can remember, and which is, there's typically a way to work historically with data, which is you have a data platform, and the data platform is kind of like the piece of infrastructure that is going to allow a specialized team with some domain expertise over data to help everybody else literally in the company to access the data and get value out of it. And everybody needs data for different reasons. They range from marketing people to sales to product to operations. Obviously, the data is very useful because it's where like like what makes your business specific is captured. But traditionally, all data work funnels through the data platform team. And I know that there are like several other models like the data mesh and like kind of like data products, but it's very customary to have like some forms of centralization in this process. And in my experience, organization kind of like often swing in and out. So you kind of like between like two contrasting needs, because one is of course is the need of control of like letting the business stakeholders and the people who need the data closer to the use cases to be able to access the data and ask the question that they want and process the data that they want to process. And at the same time, you have like that usually leads like to a fairly complex situation when it comes to maintaining order and control around data, like governance. Data quality is a big deal in that sense. Table sprawl is another big problem that you tend to have when you open the gates in a way that is not well thought. And so you kind of like then swing back to another kind of like fundamental need of how you run a data organization, which is you want to maintain some certain control in the middle. And in the AI era, this problem becomes like even kind of like more complex to solve because everyone in your company probably has access to a Claude Code agent or a Claude agent from, if you're a knowledge worker, from Claude Cowork, for instance. And the agents, of course, need access to the production data and to the enterprise data because that's what makes the agent able to reason about your specific questions about your specific business. But clearly, the data engineering team cannot just like grant access to every Claude session that any person around the company has open because the agent is an untrustworthy type of thing and can do things on the data that we might regret. We want to maintain control and a good understanding of what happens on the data. So today there's really no simple way to just get basically people who are just like using Claude to just like wire Claude to production data and use Claude to do things that are meaningful that can manipulate the data. And that's really like what our abstractions and the way in which our platforms, Git for data is one important component of our platform, of course. is really like built up to solve. So Bauplan is essentially a data infrastructure that is built for agents as first-class users. And most importantly, like we don't really need you to use an agent that we provide or anything like that. Like any agent that your workforce is using, we keep using Claude as an example because it's a very widespread option. But like essentially, like what we believe is that in the future, more and more work is going to be done in the agentic layer, and good infrastructure that can just like be wired to the agentic layer provides like a lot of value. But we effectively allow these agents to access the production data in a way where the production data is essentially the agents can work on the production data safely and effectively. The data, every change you bring on the data is branched, is reviewed, and is reversible in the worst case scenario, which is really what Git for Data means. Git for Data is essentially just like bringing a bunch of abstractions that you do have in code, like branches, commits, which like will provide essentially a time traveling device, merge and rollbacks instantaneous over multiple tables in your data lake. We typically work over analytical workloads and data transformation workloads, so that's the use cases that we deal with. And you can basically just have now this model that is very familiar from the software engineering world into your data world. You have a branch, you isolate your work, and that data now can be used and can be modified and can be manipulated by any AI agent in a way that is secure and just like keeps the data infrastructure, like the main production environment safe. Mattia?
And Ciro,
You
we
have a
have
question?
a
Okay.
first question. I think it was driven by this visual.
Nice.
So, would you guys actually let the agent merge to production without a human, like checking, approving the diff?
No, not really. That sounds like a awful idea. So that's not what our customers do. But I'm gonna show you in the demo what that process works. What typically customers do is they have agents that author the data and handle the end-to-end pipeline. But then there's always a moment where like humans are in the loop. And I'll show you how that is. Like there are several ways to
And
do that, but we have integrations with typical tools that people use like GitHub and so on.
we also have a more advanced question. Let me copy and paste it here. Which is basically how do you handle like conflicts? So if you have more than one agent, so if you have like two agents branching from main and both merging, Git has merge conflicts. So what is the data equivalent?
So there's a couple of things there. Like the merge conflict per se is usually kind of like a diff against the tables. So like dealing with a conflict there means like to make sure that whatever agent A authored and agent B authored don't conflict against like the same rows in the same tables. In practice, when you use a platform like Bauplan, the conflict happens much less frequently than one would expect. And that has because the way in which you author a job and you publish a pipeline or you publish a table goes through a way of writing the table in code that makes basically your code in your table practically the same, like practically like tied in a way that is like you have one function and that function corresponds to a table. So to have a true conflict, you kind of have to have two agents writing the same function at the same time, the same repo with the same name, which happens very like it doesn't happen very often. And that design was also chosen to for a number of kind of like a good ergonomical reasons, but one of them is this. It's kind of like to minimize the possibility that agents kind of just like conflict all the time. But in case that happens, like Bauplan will run a diff and will tell you, hey, this merge will conflict. So you might want to kind of like go back, rebranch, and rerun. Um, like Git for Data is very much like one of the components that we think like a platform that is like truly designed for agents should have. Other examples of that would be just like the fact that we're great believers in the fact that whatever capabilities you bring to the agents should not really, ask any data practitioners to move from where they are. So the way in which we design the platform is that you might want to have like this agentic ergonomics and this agentic layer for giving access to the people who are working on Cloud Code directly on your data, but you certainly do not want to move from your existing infrastructure that you built painstakingly in the last, like 5 to 10 years. So what we basically do is we embed Iceberg and we handshake with whatever you have in your infrastructure, and we don't need you neither to migrate nor to actually have Iceberg in place. So that's a very important design point for us. Like we think Iceberg is super useful to make your platform entirely interoperable. We don't necessarily see a lot of value in just like asking people to adopt Iceberg themselves. Like it's an implementation detail, is abstracted away. We use it as a way to talk to other systems, and that's it. But when you think about like how to integrate these capabilities in your platform, you should think about the fact that you can keep basically your governance and your catalog and your main operations into the large platforms that you design your stack around. And then you have like the possibility of just like handshaking with Iceberg and using Bauplan for more agentic first workflows.
Yeah. One
Yep.
sec, I think. Let me copy and paste here.
Go
So
ahead.
that's a question that I personally like get a lot, which is
Mhm.
how do you guys integrate with Databricks, like specifically?
So Databricks, so specifically Databricks has usually so the integration that we typically have like go through Unity Catalog. A Unity Catalog does support Iceberg as external tables using just the REST protocol. To be honest with you, that integration has been a bit wonky on the Databricks side, like throughout the months. So it is like sometimes it chokes, but that's basically how we integrate there. So what you typically want to have is your tables that are managed in Unity Catalog. There you do like your governance, and then you register as external tables in the Iceberg format, the tables. We plan on supporting Delta. Right now, we mostly do Iceberg. Right now, like we embed only Iceberg because I understand that most people on the data catalog of Databricks will kind of like implicitly end up using Delta just because. So yeah,
Thanks. Thanks.
yeah. So when you go back like to the concept of just like getting like people access to Claude, and getting their Claude access to the data, you end up like in situations where you do have a varied population in your company that now can just like, legitimately ask for, I would like Claude to do certain things on the data and just like, for instance, build a pipeline or an analysis for me. And these people might be just like from the marketing team or from the finance team, from the sales team, from the product team. So they don't necessarily have to be like very technical stakeholders, but certainly are stakeholders that understand the business very well. And the problem in general is that if you have like, which I think is the origin of that kind of like swinging back and forth that I was mentioning before, like behind a simple request from, for instance, somebody from marketing, like a simple request like the one that we're going to see in the demo, which is like, hey, I'm prepping like the Q4 re-engagement campaign and I need to understand a little bit of data to prioritize. I'm going to just like get last week's shopping activity and just like, can you tell me which segments are actually worth spending my ad budget against? Here's a bunch of data that I have that I pulled out of another system or I just like collected. Can you build a dashboard? This is a very reasonable, request if you're a marketer. But like to do this like in a lake house, it's actually a lot of work most of the time. So you kind of like have to ingest new data in the data lake. You have to build a pipeline. You have to check the quality and test for the pipeline, make sure that the pipeline is not going to change existing tables, for instance, that other downstream consumers trust. Then you're going to go through a process of publishing the new pipeline. Then you're going to create a dashboard. You're going to get it back to your marketing person who asked for it. So like there's always like this kind of like mismatch between the business stakeholders that is go like, well, I need just a dashboard. But in practice, like, data engineering is complicated and you're managing a system that is kind of like stateful and evolving over time. So, like this is the kind of stuff that is behind the hood. So going back to the Git for data, what we see in the market right now, like what we see our customers doing is we can use the Git for data now to essentially help people to self-serve with agents and keeping the data engineering team looped in a way that doesn't lose control. And we use like the branching system to allow the agents to do complex workflows because one of the fantastic things about AI is that you can have now forms of automation that just that were like just impossible to conceive just a year ago. So you can actually ask like a complex end-to-end workflow to your agent, and it can do that like end-to-end, and then you're going to have a moment when you review a merge. And so going back to one of the questions, like, no, you don't let the agent merge. You typically have like your data engineering team, your data platform team involved in that process. But crucially, the data platform team is not longer involved in every step of providing the data and the pipeline to the stakeholder. The stakeholder can just like spin up an agent to do that. And if you don't have like any other question, I can just like jump into a demo and show you how this works, like, kind of like minimal setting.
Yeah, I think we should.
Okay. So going like, imagine that we have something like this. Okay. Imagine that we have just like Claude is wired up to Slack, for instance, and I am a marketing agent, and I'm a marketing expert, and I have this kind of like little marketing agent inside of my Slack. And what I do, I can just like ask the very prompt that I showed you before in my Slack channel. Okay. And then just like what I do. Now, for the purpose of this demo, we're going to activate our own agent. Okay, like in a real setup, like the agent is kind of like listening to this. But this is to show you like what the agent does behind the hood. So once you have like the prompt in Slack, the agent's now going to check for it, and it's going to read the prompt, and then it's going to use the platform, the data platform with the Git data, with the Git for data ergonomics to basically to provide like what the user is asking for. So you see just like there is a data and there is a data request. The agent basically just like answer, hey, I'm on it. We can work on this. And the first thing that we're going to do is now get the agent to break down that request into a number of operations that correspond to a number of skills. Like the first one, for instance, will be, well, we have to import this data. And so we can just like use the first skill, which is called safe ingestion. So safe ingestion means that we're going to open a branch, and we're going to allow the agent now to write a new table inside of our data lake using the branching system. So it's going to write the table inside of a branch. The table is not just yet ready to be read by all the others downstream consumers. It lives in a separated branch, and like we're going to publish that later so that other systems can read from it. But for now, we're going to keep it like contained in the branch. How does it work in practice? Like how do we create branches, and how do we access those branches? It really boils down to the agent just like using the APIs that we provide and writing some code. So the agent in this case, for instance, will just like write a simple script here that is going to use our client to just like ask for a bunch of things like, check whether the branch does exist, create a branch, and then create a table inside of that branch and import the data in the branch, and then run a validation just to make sure that the data that we imported does exist, and like it corresponds to the schema that we expect. Like the validation can vary, but like essentially the way in which the agent manipulates the data infrastructure and creates branches is just through code, because that's what the agent is very good at doing, like just writing code. And you have this simple script in your repository. You can now commit it to your to your GitHub repo, so you can version and you can reproduce end to end whatever the agent has done. Because it's another important thing when you work with agents, is having good ways to reproduce everything that happens in case something goes wrong. So the first thing that the agent, yeah, go ahead.
Yeah. So we have a question about like importing and ingesting, which is a very simple one. You say like ingest, is the data already in S3, I think. What does it mean importing or ingesting in Bauplan?
Oh, in this case, we're basically talking about the fact that we do have some data in S3, and we want the data to become like a table, an SQL table you can run queries on, and you can do optimization on. And so what this comment here will do in create table is creating an Iceberg table for you, and it's importing the data into the Iceberg table, so that from now on, the table exists in the lakehouse, in the branch that we created. And if you want to run, for instance, an SQL query against it, you can just do, select star from table name, and you just like get your normal SQL table. The data can be anywhere, but like,
Okay, so basically it's like importing to Iceberg. So the data is already in
Yeah,
S3
yeah,
and okay.
yeah.
So, and very simple one is what is happening when you are branching? So what is happening to the data under the hood?
So what is happening to the data when I branch is I am creating a zero copy, so a copy on write branch of, in this case, the entire data lake or a namespace, like a portion of the data lake. But what that will do, it will create a kind of like a metadata pointer to a new branch of your data. So now when you write, you're going to write in this logical copy. What it does not do, it does not copy the entire data all the time. um, I mean, it would be impossible to be like this fast. Like, as you can see, like this whole thing is like doing his work like pretty quickly. So, and also it will create like a whole number of problems in like just like managing your storage. So yeah, so basically just like it creates like a new manifest file that tells like, hey, there's a bunch of tables now, and these tables, this version of the tables correspond to a branch. And a branch is very much like in a Git branch. A branch is basically just like a head of a chain of commits. So you can always like travel back and forth in time. So it's a little bit like it's both a multiverse and a time traveling and a time machine. So if we go back to the flow that the agent is implementing, we have like ingested like 8 million rows in this specific branch, and that's the first step. The next step will be just like the data is clear, so I can build a pipeline. This data is fairly simple. And so what I was saying before, like the workflow is split in different skills. So the next will be just like loading a skill to create like a data pipeline. A data pipeline then is basically, once again, a simple Python script that we have here. And the data pipeline contains a lot of information about how you run like the entire pipeline just expressed as code. Like an example of that would be every single node of your pipeline will be using certain packages to run in the cloud. And those are declared here in the code. The node of your pipelines will have columns that they read directly from S3, for instance, from an Iceberg table, and they will be declared here. They will have a definition of your tables in kind of like semantic form, and they will sit here alongside with the code in a doc string. Then we'll have like the actual manipulation, like the actual transformation logic. And then your pipeline is basically a very simple form of functions that are chained together. Like every step of your pipeline, when you see here, for instance, in the DAG, I'm sorry, you see here in the DAG, like you will see that this is like node number one, and this is going to be basically node number two. And everything you need to know about this transformation is going to be expressed here in code. And the reason for that is that we want Claude to be completely aware of the full execution environment, and the data contracts and the semantics should be readily available for the agent to put in the context and reason about it.
You
Um,
know, we have
yep.
two questions about like storage and materialization. So the first one
Mhm.
is what amount and kind of data is being retained on the Bauplan platform?
Throughout time, this is a parameter that you decide.
No,
Um,
but what kind of data is gonna stay and retain in the data in the Bauplan platform?
Nothing. Like the data, like the Bauplan platform per se is completely is ephemeral compute on top of your S3 bucket. So every state of this pipeline, everything that you want to persist is going to be persisted through a materialization strategy, which means essentially you can replace a new table inside of your data lake, or you can append new data to an existing table. But everything is always in your premises, in your storage. We don't store any data. We just send the data to the runner. The runner is going to process that ephemerally, and then it's going to just like disappear.
The second one is correlated to the first one and to your answer. So if I get it right, a portion of the new data written within a branch will be hosted on a specific portion of the S3, but just the diff between the main branch and the current one. Am I correct?
Yes. So you ultimately write everything you need to write inside of your same bucket, inside of the same data lake. The system is going to have a bunch of logical copies to make sure that they write only the deltas. and they're going to just like reroute the query engine and your data catalog to the right branch and to the right portion of it. Yeah, you got it right.
And one more. Does the
Yep.
ephemeral compute use DuckDB?
The ephemeral compute use whatever you want. So an example of here is like, because if the way you think about the ephemeral compute is, imagine that this is basically just like a function that we run in a container for you, like it was a Lambda. It has a number of optimization that makes the compute much faster, that makes the function able to read directly from S3 with a number of optimization, like filters push down and predicates push down. But ultimately, what you decide to use inside of your function is up to you. I can ask now my agent to rewrite this function here instead of using DuckDB to use polars or pandas or arrow, whatever library you think you want to use to run this. You can also express this transformation as pure SQL queries, like you would in a more DBT-like fashion. And in that case, Bauplan will use data fusion for you. And you don't have a choice in that case. But like if you want to have a choice, you can just like express here polars and your version of polars, and then you write polar or ask Claude to write polar's code here, and this is going to be exactly the equivalent.
Awesome.
Yeah. So in terms of what the agent is doing now, like when you do like the data pipeline, what happens is that we generate the data pipeline, and that's okay. And then we run it, and we run it in the cloud directly, right? So the first thing you do is you run with a dry run, which means like you run it, and just to see that the code that you wrote makes sense, that the data flows right. Then you actually write results. So you actually write the tables inside of your data lake in the branch that we are operating. And if everything looks good, then you load another skill, which is data quality checks. And now you make sure that whatever data you're writing in this branch actually passes a bunch of data quality tests, which tend to be like expectation tests out of the box. You can customize the entirety of that. You can write whatever test you want. You can instruct your agent to do everything like through the skills, but like out of the box, it just comes with a bunch of pre-defined data quality tests that are like data expectations. If those
Um,
pass, and we can like the system is built in a way that we can enforce the data quality test to make the pipeline fail. If that pass, then we move to the next step, which is building the actual dashboard, which is where we are now. Matt, you were
Meantime,
saying
we have a
something?
couple of questions. So we have
Yeah.
a question about like SQL, like compatibility, or
Mhm.
let's say, so is the full subset of SQL that DuckDB and Postgres supports handled by Bauplan's Data Fusion SQL parser?
Like Data Fusion has its own SQL dialect, like every other SQL engine. So you're gonna write SQL, Data Fusion SQL, which is fairly similar to the Postgres dialect. So it might have like little like changes here and there, but like it's not a terribly it's not exactly anything that requires you to refactor a lot, especially these days when you ask an agent to do that. And Claude can write really good SQL across like different engines. Your if you want a specific dialect, like you use this way of writing it here, right? Where you basically load it inside of a container, and then in the container you do whatever you want, like it's your container, so you can literally do whatever you want.
And we have a question from the Q&A panel that I copy and paste, which is a
Yeah.
very different one that most probably was triggered by the token counts. So agents already burn a scary amounts of tokens, retrying, does branching and all of this stuff with like it for data make it better or worse?
So look, the question about the tokens is a very important one. It becomes like more and more important every day. Our answer, like a short answer to that, is that we design a platform to be extremely token efficient in terms of what the agent needs to know and read to operate the entire system. Just to give you an order of magnitude, if you wanted to instruct an agent to use like the CLI of major platforms out there, like kind of like Databricks or Snowflake or BigQuery, the number of tokens that the agent needs to read is in between like 3 and 5 million. The entire platform of Bauplan is expressed in 60,000. So like we're very, very mindful of that. Because we think that the more people use agents, the more like the cost center will become like tokens. As far as the iteration goes, it's an interesting point because I think like the branching system allows you to deploy potentially agents that are simpler. So like you don't have to use a frontier model all the time. You can use a stupid model if you want. You can have like, which is cheaper and more, but it's gonna make more mistakes. And so the branching system will allow you to use, I don't know, like Quen, for instance, and make sure that with the branching system, you can kind of like brute force your way to a solution. The agent is gonna just like try, fail, open a branch, fail again, open another branch until it converges towards a solution. If you're familiar with like patterns like, I don't know, auto research or Ralph Wiggum, that's pretty much like the type of design that some of our customers have used for tasks. Of course, these are not tasks that are like super time sensitive because like the agent is going to stumble upon this like for a while. So yeah, for instance, if you want to migrate the data from one system to another, this is a fantastic way to do it automatically and very effectively.
Yeah, and we have tons of materials, guys, if you want to know more. Okay, please
Yeah,
keep
because
going.
like I think also like that's going to be like the future, like more and more. Like I honestly think like right now, like a lot of our agents are very synchronous. So is in like like you're in front of a terminal, but that's going to move into agents working in the background, like more and more. And so like a good system to control that is really needed. But at the end of the day, so this is what happens when the whole process is done. So if I like you can see like we're completed the process. I don't know if honestly this worked because that's the thrill of doing demos with agents. Um, but basically, I'm back to the marketer. So now the marketer who asked this question just like sent this question to Claude. Claude built an entire data pipeline end to end, comes back and says like, I'm done. Here's what I have here. This is the branch, for instance, where you can find what I did. And here you go into the Bauplan UI, and here you can see like all the commit history, for instance, like as you can see, we had like we created a branch, we imported a branch, we ran two pipelines, and so on, right? And you can explore your tables with your query engine in SQL. You can just like see what the previews are and so on. Okay, so like for instance, like this new table that we just created here will be called like exactly like Bauplan e-commerce session week. So we can just like look for this table here, and we're gonna find this session like this table here that we created through the agent. It also tells me like now it gives me like a little bit of a simple kind of like summary of what it is. But ultimately, what you want to do is you want to give like a dashboard to the marketer. So you publish a link, and now you have like a simple Streamlit app that I can double check. So that's really the request that the marketer had. Like, can I have a pipeline? Can I have like some data that I can explore and I can visualize in a simple way? The agent did the entire pipeline and ultimately gave back this dashboard that lives in this branch and so on and so forth. So now the question about this pipeline from the data engineering standpoint is, should this pipeline exist? Who did this pipeline? What is this new table that we wrote? Like, does it matter? Is it overlapping with something that I already have somewhere else in my lakehouse? Like, how do I manage this pipeline that has been done, by an agent spun by somebody who just like posted a request in Slack? Like, I want to know that. And if you go on here, like the other thing you're going to have is a PR. So in the meantime, for the data engineering team, we also have like a PR in GitHub that you now can review. And this is really what I mean when the data engineering team and the companies are using today Bauplan are like moving from doing all the steps for the request to just like reviewing what agents do. And your PR will contain, what are the tables that have been created, what is the branch where all this happens. So you can go in the UI of Bauplan and double check what happened there, like run your queries, run your analysis. It will tell you what the DAG will looks like, what is the pipeline. It will tell you what has been done in terms of data quality. Like these are all the tests that we ran. And in this case, they passed. Do you think you need more? You can go into the branch, add more tests, run it again. You think it's fine? You think it's fine. These are the results. It gives you a little bit of an understanding of how this works and like the general the general results. And it tells you how to publish it. And in this case, what is going to happen is that if you now just like accept and merge this, we merge this pull request here. What we're going to have is that a GitHub action is going to just like run a Bauplan branch merge, which will publish these tables right away in our lakehouse. So once I'm done with this, if I go back to my to the lakehouse and double check like what is happening there, I'm going to be able now to see in my main branch, which is the equivalent of production to a certain extent, like is where all the tables that other systems trust are. I have like my new publish via PR. So I have like this publication here, and I know that what happened here is that I merged like some new tables. And that's really kind of like how you handle through the agent. Like you can let the agent loose on the data, but you don't really like you don't lose control over the process of reviewing all these tables and making sure that these things like are done in a way that the data engineering team like keeps an eye on it. That's it.
Yeah, we have a question
Mm-hmm.
again on the Q&A panel that is about like commits. So
Yeah.
every agent action is a commit, but who wrote the commit? So how do you audit which agent did what when you have 10 agents like running in parallel?
That's a very good point. So from the point of view of the data platform, because you bring the agent is essentially a user with certain RBUC privileges. And then what our customers typically have is those agents correspond to a user that is also a user in the platform. So typically our customers do have like a way to organize their agents and the identity of the agents irrespective of Bauplan. And that's really kind of like the way we think about that. Like I don't necessarily want to have a agentic layer and agentic management platform inside of the data platform. I believe that you will have to manage agents across your organization more and more everywhere. And so we're kind of just like read those, so we integrate with those platforms on top. But from the point of view of the platform, the agent is basically another user. Like an example of this would be if we go back to our PR here. Yeah. Like RPR was built by a Claude agent that corresponds to myself, and it's called like the username in this case will be where is it? There's a username here that my agent has that is different from mine. And so you will be able to track the agent as the author, but that username will also be tracked, like will be connected to my account.
We have one more question about like merging. So the merge branch then will actually merge into main tables with which identity? The agent identity?
With the agent identity, yes. Like the agent identity is tied to me. Like who wrote the code, like who authored the code is the author of that merge.
And what about like merge into like main tables? Like
That depends on how you set up your GitHub.
okay.
But like in the case that I showed you, like that is a merge that will correspond to me because the review was on me, and so the like I clicked the kind of like the accept and merge the PR. But like all the identity, like once again, like we piggyback on the model of identity that you have in place. We don't want to kind of like change necessarily the way you do things with agents in general when you use like the agents to publish code in your GitHub accounts. Like whatever setup you found for yourself, like we're gonna just like go with that.
So guys, the plan for us was like to wrap it up around like 45. There is one more question in the Q&A. If you have
Go ahead.
a couple of more like questions, we can stay here 5 more minutes. So let me just like drop the one here, which is a pricing question. And I also get this one quite often, which is something like, this kind of like usage is going to bring an explosion of consumption. So is your pricing consumption based like Snowflake, like everybody else? Agents running checks and merge all day makes that kind of like pricing terrifying. So how does
Yeah, like no, like our pricing model is not really like that. So our pricing model is designed for you to have like peace of mind with agents. So you ultimately pay per compute, but you don't really pay like per query or per byte scanned. You pay for like a certain amount of capacity we allocate, and you basically pay for how long you want to wait, really. Because like things are going to queue in that capacity that we allocate. We can auto scale, but like that's not really what you want to have. Like you don't want to have a spiky pricing model when you have like agents running. So Bauplan is designed for you to have agents that, for instance, in the example before about agents iterating. Imagine that you have an agent that iterates and makes like, I don't know, 200 mistakes before getting it right. I don't think you should pay for 200 mistakes, frankly.
Good. So I don't see any other questions here in the panel. Guys, if you don't have any other question, I think we can wrap it up. We're gonna have our webinar number 11 in 1 month from now. So stay tuned. We're gonna obviously like promote it in every channel of Bauplan. If you have any question related to what Ciro discussed today, feel free to ping him, to ping me. We're always like very, very open and very happy to talk to all of you. So
Sounds
thanks
good.
again and see you next time. Bye,
Thank
guys.
you. Good one.